All right, numbers 4 and 5. Number 4 first. -7 equals a minus 3 all over 4. Now, when I am teaching you how to undo it and decide what needs to be undone first, what I tell you is that you're undoing order of operations. Whatever happens last is the first thing you undo because you're going backwards. So the last thing that happened is the first thing that you encounter going backwards and the first thing you undo. So this type of problem, it can be a little bit confusing because if you say, oh, well, in order of operations, division happens before subtraction. So if subtraction happens last, I have to undo that first, okay? The trick of this is, and you need to know this about mathematics, is that invisibly there is a parentheses written here, okay? Anytime there is this fraction bar with an expression on top and potentially an expression on the bottom, you need to know, even though you're not seeing it, that there is an invisible parentheses and everything on the top has to get done and everything on the bottom has to get done. The division then happens after you've resolved this. So when you're analyzing this, actually this is parentheses, that happens first because there's invisible parentheses and then the division. So the division becomes the thing we undo first. This is one of those trickier things about order of operations and solving equations, okay? There is invisible parentheses there. So since this it would be the first thing that would happen if you knew what a was and then divided by 4, we undo divided by 4 first with a times 4. So 4 parentheses, everything that's there, equals 4 parentheses, everything that's there. Remember, when we multiply to undo division, we put the 4 outside to the left and then everything inside. Okay, now we simplify it. 4 times -7 is -28. These undo each other to be a minus 3. Now we have a one-step problem. The only thing happening to a at this point is 3 is being subtracted from it. And how do we undo -3? With a +3. So write everything that's there on the left-hand side, and then your change at the end, +3, equals everything that's there on the right-hand side, and then your change of +3 at the end. If it happens to one side, it happens to the other. Okay? Now here, your -28 and a +3, these are opposite signs. That means these 3 positives will cancel out 3 of these negatives, and you'll be left with 3 negatives less than you had before. You had 28 negatives, now you have 25 negatives. And these two undo each other to be a. So -25 equals a. For your proof, you rewrite the original equation. -7 equals, now you put parentheses where there was a variable and the value of that variable inside, and rewrite everything else exactly the same. Now, because this is now a numerical expression instead of an algebraic expression, there's no reason why we can't just solve this right-hand side down to a single number. It's all numbers, we can do it. The first thing we do, again, is we have to resolve this top of the fraction bar. -25, take away 3. We're down 25, we go down another 3. When I say down, I mean we are in the negatives. 25, and then we go 3 more into the negatives. We're going further into the negatives, so we should have a bigger negative number. Yep, -25 minus 3 is -28. Everything else gets written the same. -7 equals, this resolves to -28 over 4. And now we can do this. Negative divided by positive is negative. 28 divided by 4 is 7, so -7 here, and that matches this. -7 equals -7. Check. Let's do number 5. Excuse me. Okay. 7 plus z over -3 equals -5. Okay. Be careful here. This is z, this is 7. It can look confusing. Some kids write things in such a way. You got to make sure that the way that you write your numbers is clear enough that we can tell what you're writing. An example is I have some kids writing a 9 like this, and then they write their 4 like that, and it looks very much the same. What can you do about that? You should be closing that 9 and making that a clear closed circle like that. Then you can see the difference between one and the other. Hopefully that makes sense to you. So what we're looking at here is a situation where there is invisible parentheses here. So rather than do division and then the addition, and therefore undo the addition first, this actually is the thing that would happen first if we knew z. We do 7 plus the value first, then divide by -3. So the last thing that happens is divided by -3, and it's the first thing we undo. Okay, so we undo that divided by -3 with a times -3. This is an example of why we have to put the number we're multiplying by to the left. Because if we wrote it to the right, times -3, that doesn't say times -3. That actually says -3. Okay, so by always putting it to the left, it's going to ensure that we don't run into this error where we wrote it to the right by accident, and now it's actually saying something different than what we mean. We mean to multiply by -3, not subtract 3. So we will put it on the left-hand side. Okay, -3, parentheses, everything that was there, equals -3, parentheses, everything that was there. We chose to multiply by -3 because it undoes divided by -3, and these two things cancel out, leaving just 7 plus z. On the right-hand side, we've got a negative times a negative is a positive. Be careful about that. I see kids often just accidentally not translating one of the negatives down, and then when you're doing the calculations, it's going to equal something different than what you meant. -3 times -5. Negative times negative is positive. 3 times 5 is 15. 7 plus z equals 15. Now, we're always undoing what's happening to z to get it to just say z equals. We're isolating the variable. Isolating meaning getting it all by itself on one side of equals with nothing else there and with a coefficient of 1. This already has a coefficient of 1. If you don't see a number in front, we know it's an invisible 1. So the only thing we have to do here is undo this plus 7. And how do we do that? With a -7, right? Everything that's there first, -7 equals everything that's there first, then -7. Okay, these two undo each other, leaving just z. We don't have to write this plus now because it's just that plus makes this a positive z. And since there's nothing else there in front being added to it, it can just say z. Okay, 15 minus 7 is 8. Put a box around it. Now, to do our proof, we rewrite the original equation, and then wherever there was the variable, we put parentheses and the number inside. So 7 plus parentheses 8 over -3 equals -5. And now, as I said earlier, there is invisible parentheses here that tells us that we need to do this first before the division, okay? Normally, in order of operations, division comes first before addition, but this invisible parentheses is putting it to the front of the line. So we say 7 plus 8. 7 plus 8 is 15. Everything else is written exactly the same for the moment. Divided by -3 equals -5. Now on this step, we do the division. Positive divided by negative is negative, and 15 divided by 3 is 5, so -5 equals -5. Check. There you go.